All right, hey guys. So we're going to, I guess, in a manner of speaking, backtrack a little bit. With some of the questions I got, some of the things that we've talked about. Kind of, let's go back and look at a few things before we move on. So, electric charges. We have all done this where you reached out and you got a shock from the doorknob. So, what was that all about? In order to understand this, we got to understand a little bit about electrical charges. So, some things we know, so you don't have to write this down because we did this in our chemistry unit, but all matter is made up of small particles called atoms. Inside of an atom, we have three subatomic particles, or slightly smaller particles: protons, neutrons, and electrons. All right, so protons, neutrons make up the center. We know that. We're all up in here with our protons and neutrons. And electrons are flying around the outside in the electronic cloud. Protons and electrons are the charged portion, with neutrons being neutral. So once again, we should know this. This would be like lithium, for example. Charge is a physical property. We talked about this a long time ago when we talked about, physical and chemical properties, the difference between the two. An object can have a positive charge and a negative charge, or no charge at all. So charged objects exert a force on something. We've talked about forces, as we talked about Newton and all that good stuff. A push or a pull on another charged object. So we've seen a magnet. We've thought about, you understand general magnets. The plus and the minus pull apart or pull together. Plus plus kind of push or try to stay away from each other. So attraction, positive, negative, and we should know this: positive, positive, and negative, negative. Those are going to repel or push away. Objects that have the same charge repel each other. So plus, plus, they're going to push each other away. Now, on the flip side, we have things pulling together or attraction to one another. So if you have a positive and a negative, they are attracting to each other. Here, like it says, we can either have a push or a pull. This time we are having a pull because they're coming together. And the last one, we had a push because they are coming apart. All right, so wax and a wool cloth, sorry. Going to have positive, going to have negative. They'll be attracted to each other. All right. In atoms, protons are positively charged, electrons are negatively charged. Okay, we should know that from our symbol of E. Goodness gracious, that's a bad E. Hold on. That's not a whole lot better, but E negative, right? And protons are positive. Because protons and electrons have opposite charge, they are attracted to each other. Without this attraction, electrons would fly off. So have the slight attraction here, because if they didn't, they would just go wee and fly off. The force between charged object is an electrical force. The greater the charges are, the greater the electric force between the two objects. So if you have a strong magnet and two strong magnets, that force is going to get stronger. It's going to be strong. If you have two weak and weak magnets, they're going to be relatively weak. The closer the objects get together, the greater the force is between them. So we've probably felt this maybe in our lives with a magnet. You get it close to something it's going to attract to, and it gets hard. It gets the force. You can feel it pulling harder towards, like the fridge magnet or something. Charged things have an electrical field around them. So here you can see the two positive charge pieces are repelling each other, pushing each other. The positive and negative, they're having an attraction towards each other. They're pulling together as opposed to pushing apart. So the electrical field is all around. There just happens to be two examples of them. So once again, pushing apart, pulling together. Electricity is simply the presence and or flow of the electrical charge. So atoms have an equal number of protons and electrons, just off the base periodic table. Because atoms positive charge and negative charge cancel each other out, they really don't have a charge. Now we know they form ions or charged particles to form atoms and molecules, so they can change this outer portion. They cannot change the inner portion. Remember, that's all in the nucleus, so that stays put. So they're going to trade or barter and share the electrons. Objects become positively charged when they lose an electron, and when whatever gain that electron becomes negatively charged. Okay, so here we are transferring one from this guy to this guy, so he becomes positively charged, he becomes negatively charged. Remember, the gaining of an electron, you become negative. You're getting a quote unquote bad thing in the analogy that we've used in class. All right, so objects can be charged when electrons are wiped from one object to another. So we've all done this thing with our hair and the balloon, all right? Make our hair stand on ends. We turn our hair slightly negative to a balloon portion that's slightly positive. So it'll kind of pull up our hair. Here we have rubber and like a piece of fur or fake fur. You can rub it and it'll create a negative charge on this end and a positive charge on this end. You can hold this up and it'll, attract a negative thing. Or sorry, a positive thing because it has a negative charge. So charge by friction, what the electric charge of the amber after being rubbed by the cloth. So here we have 2 protons, 2 electrons, 3 protons, 3 electrons. Rub them together. We traded some of those electrons. We kind of ripped 2 off here. So the amber becomes a +2, or sorry, a -2. My bad. I gained electrons. So -2. And this becomes +2. Not really going to expect you to know that off the top of your head or anything, but just to give you an example, it's gained those 2 electrons. So now this has a negative charge and this will have a positive charge. And if you were to bring them close enough together, they would be attracted like a magnet. Van de Graaff generators. This is that machine that you've seen. You can go to the Fernbank in Atlanta, and they have this. It has this bulbous kind of top, and looks like stuff coming from it. You can touch your hand on the dome. The electrons are transferred from your hand all the way to your hair, that making your hair stand up on ends. We've seen this. You see this in old or horror movies and stuff like that. They're harmless by and large, but they can do some pretty cool things, or you can get some pretty cool little results out of them. Object can be charged when it is uncharged. Metal objects are rearranged without direct contact with a charged object. So it's randomly assorted, and then it becomes organized, where you have your positives on one side, your negatives on the other. So this would attract here. And we'll talk more about magnets in about 1 or 2 videos. So remember that original question earlier, reaching out for the door and getting shocked. What about the fire starting activator? So we didn't do that activity because we're not in school right now. But why do you think this happens to us now? One of these 2 pieces becomes negatively charged and one becomes positively charged. So when you get close enough, you have a small amount of electricity flowing from one to the other, and then you end up getting a little bit shocked. Static electricity is an electrical charge at rest, generally produced by friction or induction. So we'll talk briefly about these two. Static charge, we've all dealt with it with your clothes. Like I said, it is something that will stay on an object, so you'll have those clothes that will cling to you. As clothes tumble dry, negative charges are lost by some clothes and built up on the other ones. So essentially, it's like the pants have positive charges and the clothes have more negative charges, so they are attracted to you. This is obviously a very large example. So how this works is if you have negatively charged particles in the clouds and positively charged on the ground, you get a discharge between the negative and the positive. Just happens to be, in a brilliant, beautiful, dangerous form. And you can get them from cloud to cloud. You got positive here, negative here, or just this discharge between the negative and the positive in the two areas. All right, so that's it. That's kind of a basic about electricity, charges, and things like that.